Remember that the derivative is the slope of the tangent line. You will be asked to do lots of things with tangent lines. Find their slopes, find their equations. Lots and lots and lots of questions on the BC exam in May are going to pertain to doing something with the tangent line. Lots of times we're just asked to find the slope. It's an alternate way to ask you to find the derivative. Many times we're asked to find the equation of the tangent line to some function that they give us. Since this is the first time we've pretty much encountered it at the point of knowing derivatives, I want to make some points here before I just dive into this example. When we are talking about the equation, and follow me along, this is going to seem simple, but it's the simple stuff that seems to get you most of the time. The equation of any line. For us knowing calculus, we need a slope and a point. That's what we need. Usually, they only give us 1 point. Up to this point, until we learned calculus, the only way that we could find a slope was if they gave us 2 points. Now we know the slope of the tangent line, the derivative. Here they gave you y, so I'm going to give the derivative as y prime. That's how we're going to find our slope. So for us, the equation of the tangent line will always involve this work. We are always going to use the point-slope form for the equation of a line. This tells us, there's the 3 things we said we needed. We need a slope and we need a point. Our slope is going to be the derivative. So we're going to have equations of tangent lines, and the point that they give you is always x1, y1. I find that at this stage, students are just married to the slope-intercept form of a line. That's what they've dealt with most. It's what they're comfortable with. And so what they do is they don't realize it, but they start at this form, and then they'll use algebra to put it in that form. This is the equation of a line with the same slope going through the same point. They didn't tell me, give me the equation of the tangent line in slope-intercept form. We are going to use exclusively point-slope form, because all we have to do is find our derivative, evaluate it at the point that they told us to, x1, and then write down the y-coordinate of the point they gave us, write down the x-coordinate of the point they gave us, and we're done. That's the process we are going to use. So let's do that on this example. Find the equation of the tangent line to y equals x squared minus 2x plus 2 at the point, here's the point of tangency, 1, 1. Well, for us, the slope of the tangent line is the derivative. And we know derivative rules. That's a power term. Power pops down front, copy down my variable, reduce the power by 1. Break the habit of writing something to the power of 1. It is understood, so don't be putting it there. Next term, I pop my constant out front, and the derivative of x is 1. The next term is a constant. The derivative of a constant is 0. So y prime at any input value is 2x minus 2. I specifically need y prime at my point of tangency that has an x-coordinate of 1. The slope is 0. I'm still going to use the point slope form for the equation of a line because I want you to see something. I have y minus y1, there's y1, equals the slope times x minus x1. I'm going to pop down here, y minus 1 equals 0, or y equals 1. Here is the equation of the tangent line to function y at the point 1, 1. It is the horizontal line y equals 1. I could equivalently go here and say the slope of the tangent line when x equals 1 is 0. I know that any line with a slope of 0 is a horizontal line. This particular line better contain this point. So the equation of the tangent line is the horizontal line y equals 1. But if you don't want to make all of these connections, you can use the point slope form for a line. This is as correct as that. No difference. Let's work this next example. Find all points on the graph of y where the tangent line is horizontal. The tangent line is horizontal. If I have a tangent line that is horizontal, the slope of that tangent line will equal 0. The slope of the tangent line is my derivative. They might as well have said where y prime equals 0. That's the process I'm going to use. You have to be able to turn language into symbols just as easily as you turn symbols into language. When you have a horizontal tangent line, they're telling you your derivative equals 0. So let's find the derivative of this function in x. The first term, power pops down front, reduce the power by 1. Copy down your minus sign, derivatives break up over addition and subtraction. And the next term is a power term. There's my derivative function for any x value. Now what I don't need an x value to plug in here. They've told me I want to find all the points on the graph where my derivative equals 0. This is a quadratic equation. This is where algebra comes into calculus, and it comes in a lot. There is an x common to both terms. I'm going to factor that out. That is how we solve quadratic equations. So either x equals 0 or 3x minus 2 equals 0. Solving this for x, these are the x coordinates where the tangent line is horizontal. Is that what this question asks for? Find all the x coordinates on the graph of y where the tangent line is horizontal. No. It asks for the points. This is where the words matter. If this was a multiple choice question, it really wouldn't be an issue because all of the answers are going to be points. But if this is a free response question, I have many students that would stop right there and say, there's my answer. We have a horizontal tangent line when x is 0 and x is 2/3. That's not answering the question. So when I tell you to make sure you answer the question, you're going to have to find the points that make that a true statement. You know the x coordinates of the points, but you don't yet have the y coordinates written there. Well, how do we find the y coordinates? We need a relationship between x and y to find what y is when x is these two values. There it is right there. Y must equal 0 cubed minus 0 squared. That's 0, so there's 1 point. And y must also equal 2/3 cubed minus 2/3 squared. If this was a multiple choice question, I would have to do some addition and subtraction and multiplying there. But if it's free response, this is a correct answer. Don't take time doing simple mathematics, simple arithmetic, when you don't have to. Two things: it takes time, it eats up valuable time, and you're taking time to test. And secondly, if you're going to make a mistake, you're highly likely to make it doing that kind of mathematics. Don't do it unless it's a multiple choice question. Just walk away. We're going to work one final example, revisiting the power rule. Remember, originally, when we were given the power rule at the beginning of this lesson, we said that the power on x had to be an integer. Not true. It can be any real number, and the power rule still applies. So, we haven't talked about this notation yet. Just know that that means y prime. We will see this notation shortly. Find y prime if y equals 2x to the 11/3 plus 4x to the 3/4 minus 6x to the negative 2/3. Well, let's use all of the rules that we know. Here, our coefficient pops out front. That number, that constant, just pops out front. Now we're going to use the power rule on the function that's left, which says the power pops down front, and I reduce the power by 1. I'm going to come out of there and write this a little bit bigger. I would have 11/3 x to the, and here's what I do. I write in my head or on my paper, instead of writing 11/3 minus 1, it's my habit to write my 1 in a form that's helpful to me. So whatever my denominator is, if I have a fractional exponent, you're going to see me write my minus 1 like that. 11/3 minus 3/3 is a lot easier for my brain to handle than 11/3 minus 1. So 11/3 minus 3/3 is 8/3 plus, pop my constant out front, 3/4 x to the 3/4 minus 4/4, that leaves me a negative 1/4 minus 6. My power pops down front, copy down my variable, negative 2/3 minus 3/3 is a minus 5/3. So there's y prime. I don't have to clean it up. I don't have to cancel. I don't have to do anything. We're done. So make sure you know the constant rule, the constant multiple rule, the identity rule, the sum and difference rule, and the power rule. We will be practicing those at Warm Bodies to the Board.